Good afternoon.
Good afternoon.
Yeah.
All right. Okay, so let's see how did we do on that on those quizzes? Everybody good on chapter 5? Looking good?
Yeah. Mr. Strong?
Yeah.
So I totally forgot about the 5.1 quiz over break.
Okay.
Could I take that maybe like sometime?
Yeah. I just realized I left my pen in the other room. So, do you want to do it today, tomorrow?
Can I do it
What works for you?
can I do it tomorrow, like the hour before class?
Yeah.
Okay, and
Yeah.
then also I sent you an email yesterday because I was gone for basketball, and I just don't know if you got it or not. You got it?
Yeah.
Okay.
I got it.
Okay. Thank you.
So, yeah, we'll, so tomorrow, right before class, 5.1 quiz. All right.
Okay. Thank you.
Yeah, I hate it when I don't bring my pen, because then who knows? If it comes time and it's not open, send me an email, or a text, either way.
Okay,
But
I will.
I'll try to remember.
Awesome.
Okay. All right. Let's see. So, everybody there in Mogollon? And let's see. We got Joey gone today, right?
Yeah, and I'm gonna be gone tomorrow.
Okay. All right. So, just make sure you get the notes, and I'll post a video. I'm gonna try it. Usually, I've been doing the videos like at the end of the week.
Okay.
I'm gonna actually try to, as we get close to the end, I'm gonna try to post videos a little more often the rest of the way through. So.
All right.
Okay.
Mr. Strong,
Yes.
I did not take the 5.1 test either.
Okay. All right. Okay. So, do you want to take it right before class tomorrow?
Could we do after class today?
After class today. Okay. Yeah. Yeah. At the very end, remind me. Okay?
Yeah. Thank you.
I'll set it up. All right. So, anything else going on? Oh, let's see. I know what I was going to do. I wanted to talk to you just for a minute about the final.
And then Mr. Strong, about the final. I have a tournament on that Thursday, the first day of part
Okay.
1. When else could I take that, or could Skylar and I take it maybe
So,
the day before?
Yeah, we could. Well, let's see. You probably, if you're gonna miss that whole day Thursday.
Yeah, I think we leave like in the morning, so
Okay.
or in like mid afternoon.
So, do you think you could carve out an extra hour on Monday, the 16th? Or do you guys have school on Friday? You could take it that Friday.
I'll
next
be gone
day.
for the tournament
Oh,
that day
you'll be
too.
gone. Okay. Well,
We'll do
how
it
about
on
on Monday? If you
Yeah,
can,
we can do it on Monday.
if you can carve out an extra hour, it probably would be good to not do. I mean, you can do whatever you want. I mean, I would probably do like an hour because I've got it broken down into 2 pieces. And so what I would recommend you do is schedule like an hour and then like a 10-minute break or something, and then another hour. So be kind of thinking about that. I mean, you don't have to have a break, but the way I do the time limit on that, if people take it together, that's what I would recommend. Is just so you
Yeah,
know.
we can take it Monday morning.
Okay. All right. Well, just why don't you shoot me an email and talk it over with your talent aide and make sure that the times will work.
Okay.
And then why don't you just go ahead and in that email remind and do talk about the 5.1 quiz tomorrow.
Okay. I will.
Okay.
Awesome.
All right. That will work.
Thank you.
You bet. Any other issues as far as the timing? Okay, so let me just talk about the final here for just a second. Now, everything that I go over on the next 2 slides, I'm posting on the Moodle. So don't feel like you have to write all this down, okay? So the final will cover chapters 1 through 6. But remember, 6 is basically all we're doing with that for a couple of days next week is we're going to just go over formulas and then how to do a lot of this integral stuff on the calculator. That's going to be the focus there. So part 1 will be Thursday, December 12th during class time. Part 2 will be Monday, December 16th during class time, unless you make other arrangements. So you have to have the computer set up for Moodle access, open book, open note, and you want to have your calculator, of course. No talking during tests, use of phone or website. So this is one that I'm going to want you to turn off your phone. And so you don't have any distractions or nobody texting or whatever. Okay? Now, each part of the final has just 15 questions. So it's actually kind of shorter than a test, each one. And of those 15 questions, there's 4 which I call quick hitters, which are like matching. And so those 4 problems will take you about as long as one problem. And so that's the quick hitters. And then there's 11 multiple choice ones that you're going to have to calculate, work something out like that. Okay, the emphasis on the final is chapters 4 and 5. Okay. Now, any makeup work must be completed before part 2 of the final. So once you finish part 2 of the final, that's it. Except I've decided I was going to make the evaluation due on the day before, but I think I'm going to give you that day so that if you have something you want to say about the final. So the extra credit evaluation will be due that same day, Monday, December 16th at midnight. And then my hope is, actually what I'm hoping to do is go through the final on Tuesday and then do final grades and post them on Wednesday. But they're due on Thursday, so I put that up there. But so when you go to the Moodle, after I posted, it should tell you, okay, your grades were posted for Math 221 or something like that. So when you just, so you don't have to text me or email me. When it's posted, you'll be able to see your grades, okay? So Wednesday or afternoon or Thursday is you'll be able to see your final grade, okay? So don't go by the Moodle grade. So again, once you do, I've had some students that once they do the Moodle, they'll take the final on the Moodle and then they'll look at their overall grade and say, oh man, I missed an A by 2 points or whatever, and get all upset. But remember, I do a curve on the final and then add in the extra credit and so on. So just kind of, well, you can just know that your grade won't go down. I guess you could look at it that way. I have an 88, I've got at least a B plus, and it could go higher, okay? All right, so any questions about the final? Okay, so now let's talk about this evaluation, the 5 points extra credit. Okay, so this is 5 points on the final exam, so it's worth more than like quiz points or something like that, or even test points. So for this, you write an evaluation essay, and those of you that had me last year, it's kind of the same idea. You comment on anything in the course, the lectures, my teaching style, book, tests, quizzes, Moodle, student success organizers, anything you want, okay? And so I want you to tell me what I'm doing right and then and what you don't want me to change. But if you were the teacher, what would you do differently? And there, I want you to be realistic though, because you can't say, well, if I was a teacher, I'd give all my students A's. I mean, I would love to do that, but unfortunately, then you'd get fired. Okay, so you have to be realistic. Or if you say, you know what, I wouldn't do, I would do homework. I would assign homework to the students. Well, then you kind of have to think through that. And how do you collect homework? I tried for a year to do homework through the Talon, and finally I just gave up. As I couldn't figure out a way that I could have students have a homework grade and have it be meaningful and have it not be a hassle to get it into me. But think things through now, and then include your name and evaluation or extra credit in the subject line. So that typically what I do is I'm doing the final and the curve, I'll just look at your email and I'll just give you the extra credit. I actually don't read them until afterward. And so I don't read them until after the grades are in. And so then you send it to my email, and it's due the last day of class. So that's you'll finish the final that day in school. But you don't have to wait. You could do it today and send the evaluation. You don't have to wait till December 16th midnight. So I do want a full page. I don't want 3 sentences. Normal font, normal margins, double space. But I would like a full page. So, and if it spills over to a second page, that's not a big deal. But I want more than just a paragraph. Okay? Any questions on that? Now, I will tell you this, a lot of changes that I've made over the years teaching has been based on student evaluations, okay? These essays, they really help me, and I read them very carefully. Some things that students want to change, some things I don't have any control over. Other things that I do, and I'll just tell you right now, one of the things that I would like to change is, I haven't been real happy with the assessment this semester. So I'm actually trying to lobby the college to do like a kind of online where they verify your identity and lock down the browsers, and then you take it independently. I would like to go back to the assessments that I've done before, where students could do it at their own time and not have to coordinate with the Talent Aid or whatever. But right now, we're probably a semester away. So, I have some ideas of specifically things that I want to change on that, but it's probably not going to happen by next semester. So, so that doesn't really help you guys in Calc 2 either. But that, so I'm always at the end of the semester, I'm always trying to evaluate, what I'm doing and what I could do better. So don't if you have some constructive criticism or some ideas or whatever, that's fine. I would love to hear it. Okay. All right. Any questions, comments, concerns about this? Okay. Well, like I said, I'm going to post that on the Moodle in the section for the final exam. Okay. Also in the final exam area, I have a list of topics that you might want to review for the final. It's not really questions, but like do you know how to do this? Do you know how to do that? So on. And so that could maybe spur on your review for the final exam as well. So that's already posted. Okay.
Mr. Strong, so for the extra credit survey thing, do you have the...
Let's see if I did that yet for this class. Let me go to the... Okay. No, I don't have... The course improvement survey is up. So you could go ahead and do that. And then I'll put up the extra credit quiz, and that will take you literally 5 seconds. So once I get that up, that'll be the easiest 5 points you'll ever make. Okay? But it's not up yet. I just have it on one class, and now I've got to import it into the other classes. So, okay. All right. Well, let's. We're on 5.4, the fundamental theorem of calculus, and we are on part 6, talking about area. Okay, and we're actually let's just kind of build it up. All right, so it says area is always a positive value. Okay, and that sort of makes sense that area would be positive. Okay, but sometimes when we're calculating area with the integral might be negative. Okay, so like let's say I want to find the area between the curve here and the x-axis. Well, if I'm not careful and I just do the integral, this integral would give me 0. So you have to be careful if the question is asking for the actual area or if it's just asking for the integral. If it's asking for the integral and you get 0, that's no problem. But if it's asking for the area, then what you have to do is whenever the area goes below the x-axis, you have to create a separate integral and then take the absolute value of that. Okay. And so we're going to kind of talk about this idea several times here over today and tomorrow. So when, so let's say it says find, here's a function, find the area bounded by the function and the x-axis on the interval from -3 to 2. All right, so what I'm suggesting is that if ever the problem says find the area and not just the integral, whenever it says find the area, you want to graph it. Okay, just get into the habit of graphing just to make sure that it doesn't go below the x-axis. Okay, so for this one, so the area that we're looking for is this highlighted area right here. So from -3 to 2. So really, this is the integral. So from -3 to 2, 6 minus x squared dx. Okay? So now, so any questions on the setup? So if the function doesn't go below the x-axis, it's just straight up the integral. Okay? Now, let's remind ourselves how we do this. Okay? Because we need lots of practice. So the antiderivative of 6 is 6x minus. Okay, what's the antiderivative of x?
1/2 x squared.
Yes. And then the antiderivative of x squared, whoops, is 1/3 x cubed.
Yeah, 1/3 x cubed.
Or x cubed over 3. Okay? So then when you write the antiderivative, you put brackets around it, and then you put the limits of integration to the outside. Then you plug in the top number and work it out, minus you plug in the bottom number and work it out. Now, at any point, I mean, I like to work out as much as I can by hand, but at any point I have to start getting common denominators, I'll just put it in the calculator. Okay? And I mean, maybe you could do it without, but it really, you might as well just put it in the calculator if it starts getting crazy. So you do the antiderivative, plug in the top number minus what you get when you plug in the bottom number. Okay? So look at practice 6 on your paper. Let's see. So 4 minus x squared. So this says find the definite integral from -2 to 2. All right, so then, so let's go ahead and do that. So go ahead and work this out. All right, so Hannah W., when you get the answer, let me know.
I got 16 thirds.
16 thirds. Okay, so I got 10 and 2 thirds. So let's kind of work. So I got 16 minus 16 thirds. So let's work this out. Okay, so the antiderivative would be 4x minus x cubed over 3. So then you plug in 2. And so you get 4 times 2 minus 2 cubed over 3. So 8 minus 8 thirds. Minus. All right, then you plug in -2. 4 times -2 is -8 plus, minus -8 thirds. So that became plus minus a -2 cubed over 3. So that's plus 8 thirds. Okay, so Hannah, did you get to that point right there?
Yeah, I realized what I did. I just did the first part because 8 minus 8 thirds is 16 thirds. I just forgot. I don't know. I just didn't see that last part, and I forgot to add it all in.
Okay. So, I mean, where these are both thirds, to combine the like terms, I mean, -8 thirds minus 8 thirds, so it'll be -16 thirds, and then 8 plus 8 is 16. And so then at that point, if you calculator or not, it's not going to be too bad. So 10 and 2 thirds. Okay. All right, so then part B says find the area between the curve and the x-axis. So now if we go back up here and look at the graph, see, is there any of it that goes below the x-axis? No. So that means the answer to part B is the same. Okay? So you don't have to redo it or anything. So to find the area when it's all above the x-axis, you just do the integral. Okay? All right, any questions on that? Okay. Okay, so we must break up the intervals into subintervals on which the function is negative. Because that's when we're going to need to take that absolute value. Okay? So like here, if we don't break this up and we're trying to find the area, so let's say we calculate the area here is 2 and the area here is 2. So then the answer would be 4. But if we don't break it up and we just do it as one integral from 0 to 2 pi, we're going to get 0 as the answer. Because the 2 and negative 2 will cancel. And see, if you want the area, you can't have that. Now, if you want the integral, you don't break it up. But if it asks for the area, you have to look and see where is it negative. Okay? So, let's look at this one. So it says graph the function f of x equals cosine x on 0 to pi. So put that in your calculator. And then this interval, you want to set the 0 as your x min and pi as your x max, so that you're not seeing extra stuff that you don't want. Okay? So go ahead and put that in your calculator. The y equals, so it's cosine x. Okay, so is there anywhere on that interval between 0 and pi where the cosine is negative?
Yeah.
Yes. Okay. So that means that for part B, you're going to have to break it up. Okay? Now for part A, when it just says the definite integral, then you're going to just compute this. Whoops. Okay? All right, so go ahead and do that. So we don't have to worry about breaking it up because part A just says find the definite integral. All right, so Skylar, when you've got that answer, let us know.
Zero.
Okay. So you get, so the sine of pi is 0 minus the sine of 0 is 0, so you can just get 0. Okay? Good job.
Mr. Strong?
Yes.
So I did get that on paper, but I also tried it on my calculator and I got a really weird number.
Okay, so I haven't taught you how to do it on the calculator yet, so you're gonna have to wait. I will teach you how to do it on the calculator. So, but I'm not gonna take time today but that is part of my lesson in the future. Okay.
Okay.
So I promise I'm gonna show you how to do it on the calculator. But what in order to look at the area here, that's when you have to look at the calculator and say, all right, I've got to break this up into two integrals. Okay, so to break this up into two integrals, I've got to figure out where it crosses. So where does it cross here? Where is Go ahead.
Pi over 2.
Pi over 2. All right. So what you do is you break it up into two integrals. So you have the integral from 0 to pi over 2. And so that's going to give you this first area right here. All right. Now, the second one is going to give you a negative value. And so you have to take the absolute value of it. So you're going to integrate that from pi halves to pi. And then whatever answer you get here, you take the absolute value. Okay? All right, so let's see if you can do that. So you got the two parts, from 0 to pi halves, and then pi halves to pi. All right, so Rachel, when you've got it. All right, you need some help?
Yeah, we need some help.
Okay, so what's the antiderivative of cosine?
Sin x.
Sine x. So you're going to have sine x from 0 to pi halves. Okay, so the sine of pi halves is 1. The sine of 0 is 0, so you're going to get 1 minus 0, so 1. So this first part is 1. Okay, so are we good with that? Okay. All right. The second part, from pi halves to pi, well, the sine of pi is 0. Sine of pi halves is 1. So you get, here, let's put up a couple of more steps here. So you actually get here, so you get the sine of pi minus the sine of pi halves. Okay, so the sine of pi is 0. The sine of pi halves is 1. So this gives you -1. But then you take the absolute value of it. Okay? And so then you're going to get +1. And so then your final answer is 1 + 1 is 2. Okay? Here, I'll guess I'll. So you take the absolute value of that one, the area that goes below. Okay? All right, any questions on that? All right. So, finding area using antiderivatives. So to find the area, so now I'm giving you the notes on the process here. So to find the area between the graph of y equals f of x and the x-axis over the interval a to b. Number 1, subdivide the interval at the zeros. So in other words, you have to know where it crosses the x-axis because that's going to be your limits, change your limits of integration. And then integrate. Step 2, integrate the function over each subinterval. So, like the last one, 0 to pi halves, and then pi halves to pi. And then add the absolute values of the integral. So, if they're positive, keep them positive. But if they're negative, you have to take the absolute value because the area has to be a positive number. All right? So, let's go through practice 8 here together. Okay? So it says find the area of the region between the x-axis and the graph of f of x equals x cubed minus 2x squared minus 3x from -2 to 2. All right, so step 1, you've got to graph it and find the zeros. Okay? So go ahead and put it in your calculator and just see if there's parts of it that go below the x-axis or not. All right, so Rhett, does part of this graph go below the x-axis?
Yep.
Okay, so do you know what the zeros are?
-1 and 0.
Okay. So -1 and 0. So these two areas here that are below the x-axis, those are going to give us a negative value when we integrate. So we have to take the absolute value of those. So this is not going to be 2, but 3 integrals. So we're going to integrate from -2 to -1 from -1 to 0, and then 0 to 2. So here I've actually got 3 integrals. Now, the nice thing is, though, is that the integrand is the same. So it's not like you really have to do the antiderivative 3 times, because it's going to be the same thing each time. Okay? Let's see if you can finish this problem off.
So you take the absolute value of the second, or the first and the last one.
Right, because those areas are below the x-axis. And so if the integral should give you a negative number, and so you'll take the absolute value there. That's exactly right. All right, so Denon, when you've got it, let me know. Or if you get stuck, let me know that too.
11.83.
All right, let's see. 11.83. Great job. Any questions?
We can't see the
Yeah,
we can't see the
Oh,
screen.
sorry. I forgot. I was okay. So you get 47 twelfths for the first one, 7 twelfths for the second one, and 22 thirds for the third one.
Could you scroll up a little bit so I can see the? Thank you.
Okay. So the antiderivative would be x to the fourth minus 2x cubed over 3 minus 3x squared over 2. And then it's just plugging and chugging after that.
Mr. Strong, can you scroll down a little bit, please?
Sure. Now, is there anyone having any trouble plugging in that would like me to go through any part of that? Okay, so that's it for 5.4, and there's probably going to be quite a few questions that actually come out of that section. Okay, as far as the fundamental theorem of calculus, finding areas, the definite integrals, there's a lot in there. Okay, now let me just give you a little bit of a preview of tomorrow, what we're going to be doing there, because it's just really a lot of it is just more practice doing more integrals. Okay, now the thing about this section, when we have definite integrals, when we have numbers to plug in, I'm going to show you how to do those on the calculator. The problem is that whenever we have indefinite integrals and there's no numbers there, those you can't do on your calculator. So that's why I'm sort of focusing on teaching you the general principles as a way to do it, and then doing the calculator, because I need you to know how to do it without a calculator first. And so what we're going to be doing is what's called the substitution method. So let me just kind of show you the idea. So let's say we have a let's see. Okay, the power rule. Well, we'll do this. So this is the idea. See, this is a more complicated integral, and so we can't just do what we've been doing term by term. So we have to do what's called a U substitution. And so then what we do is we say, let's let U be this right here. And then the derivative of U is this other thing, the 6x. And so then what we're able to do is substitute and change the problem so that it's in terms of the other variable. So that's kind of what we're going to be doing tomorrow, is doing some more advanced integration that you can't do on your calculator. Okay? All right. So, David, I got your quiz set up for after school. And Chloe, you're going to be tomorrow. Anything else I need to know?